Alright, so let's get ready for y'all to do your Unit 3 test review so you can actually be prepared and hopefully do well on tomorrow's test, because that's what you want to do, because you want to do well in my class. I know y'all all do. Thank you. Let's go on. Let's move through. Okay, so first thing I'm going to show you is some quick say pictures of the answers for the review. Again, that doesn't help you if you don't know what to do, so you better make sure you know what to do. I would say pause if you need to copy these down, but you make sure you understand why these answers are there, which I will go over in a minute. Bam! There's the next picture. Oh, so let's keep going. And there's the last one. Oh, can't forget the Sudoku, because yes, that will be part of the test. Do not forget the note sheet that I gave y'all today will count as 10 points because you have to have that, and there were some things you had to fill in beforehand. If you didn't fill those in because you were just being kind of, I don't know, distracted, well then that would be your fault, and you said you didn't want those extra 10 points. Alright, moving on. Okay, so let's look at number 1. Now, on 1 through 10, again, you're looking for some type of postulate, property, whatever, that helps adhere or helps you justify the statement. So exactly one plane contains points F, B, and E. You can look at this exactly on your paper. And the answer for that one would be postulate 2.2. Now, we need to start being careful here and make sure that we put postulate or theorem, because we have now postulates or theorems that have those same numbers. Number 2, a line BE lies in plane Q. Well, again, because of postulate 2.5, which states that if you have 2 points on the same plane, then the line that goes through those points would be on the plane. So we have BE that are on the same plane, so that means that the line that would connect B to E would be on the plane too. Okay? Okay. Moving on. Alright, so what's the next one? QA equals QA. Something equals itself. That would be called the reflexive property. Reflexive. Yes, sir. There we go. Reflexive. Okay. There we go. I guess I'll put property. Why not? Okay. Next one. Number 4. So, again, all of these are right there on that paper that you have, that note sheet that's going to have all the postulates and theorems. Now, key hints. Like on number 4, notice how it says PR is equal to PQ plus QR. So if we're assuming, and I'll make sure those are drawn as line segments, that line segments PR is equal to PQ plus PR. Anytime you see something like this where you got, like, let's say, even though I didn't draw it, not PR, silly goose, QR. Even though I didn't draw it, because that's like this, where I can tell, like, say, here's P, here's R, Q, I don't care how I've got it drawn, but let's say there's Q, and you've got 2 small segments equal a long segment, then that would be the segment addition postulate. Segment addition postulate. Postulate. And there you go. Anytime we're talking, now keep in mind, if I did angles like that, like I said, there was 2 angles. Let's say here's a big angle and here's a small angle, and let's say angle 1 plus angle 2 is equal to angle 3. Let's say this is 3. Then notice again, 2 small ones are giving me a big one, so that would be an angle addition postulate. So kind of keep that in mind, because that's one way I can switch that up for tomorrow. Notice on number 5, it says AB plus BC equals E. Just key on this. Notice that there is one side. If you say AB plus BC is 1, EF plus FG is 2, and then it says AB plus BC, which we're saying is like the first thing, is equal to AC. That's a third thing. Then they give me that then 2 equals 3. That's like a transitive property. Now, I mean, obviously, don't get lost in like the long things, but notice there's 3 things they're talking about, and they're connecting all 3 of them together. That kind of is where we can tell about transitive. Okay, number 6. Number 6 is this 2 segments add up to a longer segment. Again, segment addition postulate. Number 7. M is the midpoint. Okay, we're talking about a midpoint and saying that the two small segments have to be equal or congruent. That's theorem 2.1, the midpoint theorem. Number 8, A equals B, or is congruent to B, B is congruent to C, then A is congruent to C. That again is the transitive property. You could say it's the transitive property of congruence, but we're good. Just put transitive property and I'm good. Number 9. Notice again, angle A plus angle B is equal to 90, angle B is equal to 20, and then I'm going to put 20 in place of measurement of angle B. That's the substitution property. And we use substitution a lot, especially in proofing, so keep that in mind. That is not on your sheet, but it is something you need to have. Number 10. Okay, here's where you got to be careful. Notice it says X and Y are complementary, Z and Q are complementary, and then X is congruent to Z, then Y is congruent to Q. Okay, so be careful. If you think it's 2.4 because that says complementary angles, you would be wrong. It is 2.7, theorem 2.7, which states that if two angles are complementary and there's another angle that's congruent to one of those, then those two angles have to be also congruent or complementary. Yeah, it gets a little kind of crazy. All right, so starting on number 11, we talk about always, never, and sometimes. So keep in mind here, like when you do those, you know, like what postulates or theorems can back that up. Like number 11 says a line contains only one point. That's never. And again, that's because of the postulate that says that you have to have at least 2 points for a line. So 2.3. Now, you'll only have to tell me always, sometimes, or never. You won't have to worry about the reasoning. But, you know, hey, it does help to know why. Non-collinear points, R, S, and T, 3 points, are contained in exactly one plane. That is always. And that is from postulate 2.2. Oh, I guess I should be saying postulate. Postulate. But you get it. Anyways, number 13. Most of these I'm going to have to get from the postulates, the first postulates from section 2.5. So keep that in mind. Any two lines L and M intersect. That's a sometimes, because sometimes we have lines that are parallel and they don't intersect. At least in the geometry that we're studying. Number 14. If points G and H are contained in plane M, then GH is perpendicular to M. Plane. Yeah, you got it. That one's a never. And basically the reasoning why is because it says if postulate 2.5 says that if 2 points lie on the same plane, then the line lies on the plane. So that line can't be perpendicular to the plane. Number 15, planes R and S intersect in point T. I'm going to say that one's never because, again, according to postulate 2.7, two planes intersect in a line. So I'm not going to really focus on one point. I'm going to focus on the line. Number 16, if points A, B, and C are non-collinear, then segments A, B, B, C, and C are contained in exactly one plane. That one's an always. Now, that's an always because, again, 3 points are non-collinear. That means it's on one plane. And then 2.5 states that if 2 points lie on a plane, then the entire line lies on the plane. So, there you go. Notice how each of those have those points that are on that plane. That means those lines have to be on the plane. All right, so now let's look at the proofs, okay? Okay, I hope I didn't skip anything, so I'm just going to show here numbers 11 through 16 just again, just in case, because apparently sometimes I have a tendency to do this, or I'll go to the next slide and start writing and then forget to press play again, because, well, I'm just being super smart there. Anyways, now I can see the clock is ticking, so I can tell that I'm recording, so oops. All right, always keep in mind, like, you're definitely going to get one algebraic proof, probably one where I give you more blanks, but notice here, like on this, you always start off with a given, so I could always leave that blank and make sure you put given. So you always start off with a given, don't forget, like that. And then see how here it says addition property? That tells you you're going to add something. So what am I going to add? Well, if I want to get rid of the 7, because I'm trying to get x by itself, okay, so what would we do? We would say plus 7, right? And that's the addition property. So notice how like that. Now, every time I go, like, tell you what the step is, like here I'm saying on number 2, what the step is, then I show you the results of that step. The results are the substitution. That when you show me the results, that's substitution. Okay, at least in the algebraic proofs. Now, the next step, you notice from here to here, I added dividing by 2. Okay, so that means I'm using the division property. So there's that one right there, and I've got that one done. And then finally, again, always remember the last step should always be what you're trying to prove. All right, and there you go. There's that one in a nutshell. Let's look at number 16. Okay, so let's resume recording here and go with this again. Okay, first statement is always going to be a given. Okay, and in this case, we were given that all of this right here is congruent. All right. Oh yeah, and don't forget that I did add a drawing to this. So I forgot to put it here, but we had S, T, U, and then below that you had L, N, and R. Okay. Now, according to this, by definition, congruent segments. When you see this one right here, and you want to make note of that on your paper, your note paper, that you can rewrite them as either being congruent or equals. So like SU equals LR, TU equals LN, or something like that. Okay, don't need the lines over there or anything like that. So if I wanted to go from equals to congruent, I could do the same thing. So I can go like this way, or I can go this way. All right. SU. Okay. Anytime I see like something like this, where I'm seeing adding like two small segments to give me a big segment, that's the segment addition postulate. Always remember that. Okay. So, you know, when you're seeing something like where they're adding and we're trying to say two small things are equal a big thing, that would be the segment addition postulate. Okay, now notice here I put ST and TU in place of the SU, and then I'm putting the LN-NR in place of the LR, like what I did there. And so that would be substitution. When you put something in place, it is substitution. All right, and then I put LN in place of the TU, because again, LN is equal to TU, so again, that's substitution. That one was a little bit trickier to see, so you better be careful on the test about something like that if you get something similar. Okay, and then I'm adding subtraction here, so that means I got to do the subtraction property, so that way I can get rid of the LN. By the way, could I have changed this and like done this where I would have put TU in place of the LN over here and been subtracting TU? Yes, you could have. Okay, so again, then what would I have here? I would have that based on this, I would have ST equals NR by the substitution property, because I carried out the step of crossing out the LNs. And then by the definition of congruent segments, I would have the next part. Okay, so for the last one, I notice here I'm giving you a few more blanks, but notice again, what's my first statement? My first statement should always be what I'm given. Okay, and so what am I given here? I'm given angle QPS is congruent to angle TPR. I'll get that right someday. I don't know why I keep wanting to make my P's into R's, but there you go. All right, now again, notice here I go from congruent to equal. If you just tell me that's by definition of congruent, I'm good with that. You don't have to put congruent angles or congruent segments, but if you just tell me congruent, I'm good with that. Excuse me. Now notice here I'm adding angles, so that's the angle addition postulate. And I'm not going to show you the drawing on this one, but y'all should know the drawing. It's there. And notice the same thing here. Okay. So then I try to say here, well, substitution. What does that mean? Well, if I know QPS is equal to TPR, then if this is QPS right here, I can say measurement of angle QPR plus measurement of angle RPS is equal to the measurement of angle TPS plus the measurement of angle RPS. So I'm putting this right here in place of the TPR, and I'm putting this right here in place of the QPS. That's substitution. Now, what do I want to do? I want to somehow... Oh, I may have not shown you fully the correct picture there. I want to somehow get rid of this RPS. Well, how can I do that? Well, technically what I should be doing, QPR, so I should have put this on E. So this might be a little bit different than what the picture shows earlier. Measurement of RPS minus the measurement of RPS is equal to the measurement of TPS, because to get rid of it, I need to subtract. So measurement of RPS minus measurement, that should be an angle RPS. And again, what allows me to do that? The subtraction property. Okay, and because that would cancel that out, that leaves me with QPR equal to TPS, right? Well, then I'm just going to say it's congruent, because no matter what, your last statement should always be what you need to prove. Whoops, there's a line there that I didn't need. Okay, let's try that again. So then I'm saying here QPR is congruent to TPS, and I mean, if you told me like substitution because you carried out the steps, I'd probably count that right. But in this case, we're going to say definition of congruent angles. I want, well, or definition of congruency. But I mean, if you put in there like say substitution because you carried out that step right there, I would still count it right. Okay. So, anyways, there's that. And you got, there's your say review. I'm not going to worry about the Sudoku. I mean, the Sudoku's there, but you got to figure that one out for yourself. I mean, I can't tell you too many more strategies on how to do that. Anyways, that's it for today. Hopefully y'all take this and use it to your advantage and help you do well on the test. Anyways, thanks for your time. Y'all take care.